In this video, we present some really simple techniques to write an equation for a line given some data. So what data would we use in order to write a line? Normally, we'll start with one of two scenarios. Either we'll have 2 points, or we'll have 1 point and the slope. Let's suppose we have 2 points. I've chosen these points arbitrarily. We have 5, 3, and 7, 9. And we want to write an equation for a line that will go through these 2 points. So the first technique that I'm going to show is what Collingwood calls the 2-point formula. This is a really nice way to somehow just magically write down the answer without feeling like you have to do much hard work. So what are we going to do? We're going to write y equals something plus something else. And the idea here is going to be that when we plug in x equals 5, this first term will disappear entirely. So how are we going to make that happen? Well, when we plug in x equals 5, we're going to make there be a 0 in this first term. Now, when I plug in x equals 5, this term, there's going to be some more stuff here, but it's going to be multiplied by this term. So when I plug in x equals 5, this term will disappear entirely, and I'll just put plus 3 to make things work out nicely. Now, so far this works when x equals 5. When x equals 7, I want this to equal 9. Right now, what I have is 7 minus 5 is 2 plus 3. So I really need to scale this term up a little bit. What I'd like is that when I plug in x equals 7, I'd like this term to actually compute to 6. So I'll just throw a factor of 3 here. And now I can see that when I plug in x equals 7, I get 6 plus 3. And of course, when I plug in x equals 5, I get 0 plus 3. So this works for my 2 points in question, which means it's a perfectly valid equation for my line. I want to show one other really simple technique for modeling an equation for a line without really feeling like you have to do much work. You can also see this technique in James Tanton's video on modeling a line. So what we know about lines is that if we choose any 2 points and compute the rise over run between those 2 points, we'll always find the same slope. I can clearly see that the slope equals 3. So if I choose some other point on this line, x comma y, and I compare the rise over run between this point on the line and this point on the line, I know that the slope is going to compute to be 3. Let me draw this to make things a little clearer. So what happens if I compute this rise over this run? Well, the rise over the run is certainly equal to 3. But the rise over the run is also y minus 3 over x minus 5. So I can simply write down, and here I have, again, another completely valid equation for the line, without having to really feel like I did very much work.